Hello everyone, how are you all? I am Siddharth Kumar Jha and I welcome you in the Digital Image Processing lecture series. Okay, so in the previous video, we have talked about how the human eye prescribe brightness through adoption and discrimination. So now let's shift our focus on the scientific model of how an image is actually formed. So they will help us to understand why different part of an image look brighter or darker and how lighting and object surface play a role. So in this video, we shall cover a simple image formation model on one of the most important foundation in the digital image processing. So let's get started. So let me open my the notepad for the detailed explanation about this topic. Okay, so let me make the topic or your heading, which is your image formation in the real world. Okay, so when we capture an image, what we see depends on the illumination and the reflection, your reflectance. Okay, so let me write it down. So basically, what happened when we capture in the capture an image, what we see, what we see, it depends on what illumination and your reflection or your reflectance. Okay, so what it is? So illumination is the amount of light falling on the object. Okay, and reflectance is the amount of light reflected back from the object surface. Okay, so I hope I'm clear. So the camera or the sensor record the reflected light become the digital image. Okay, so that reflected light becomes the digital image. So I hope I am clear. So how the image formation is done in the real world. So next understand the mathematical model. Okay. So let's talk about the mathematical model. Mathematical model. Okay. So the intensity of an image, the intensity of an image at coordinate x comma y can express at can express as f of x comma y is equal to I of x comma y dot r of x comma y. Okay, so where we will understand what is fxy, ixy, and rxy. Okay, so f of x comma y is nothing but your observed observed image intensity. Okay, and I of x comma y, this is nothing but your illumination component. Okay, your light source, and the r of x comma y is your reflectance component. Okay, reflectance component, or you can say object surface. So I hope I'm clear. So let's discuss about the illumination component. Okay, so let me write it down. Illumination component. So what it is? So it represent the amount of light incident on the sense on the scan. Okay, so it represents the amount of light incident on the scene. So it basically depends on the light source, your sunlight, your bulb, or your LED, and typically varies slowly across the image. So it depends on the light light source, your sunlight or your bulb or your LED, etc. And typically typically varies slowly across the images. Okay, so now let's talk about the reflectance component. So let me go to the next page. So it is reflectance, reflectance component. So, oh, okay. So it is nothing but your R of x comma y, R of. So it represent the fraction of light reflected by the object's surface. Okay, so it range is basically from 0 to 1. So it range is nothing but 0 to 1. Okay, and 1 means perfect reflection if the value is 1. 1 means perfect reflection of white. Okay, so I hope I am clear with the reflectance component. So let's take an example. So consider a white paper under a dim light. So high reflectance, so paper is white, but low illumination, it appears gray. I hope you are able to differentiate it. So in your dark room, okay, so a paper is kept whose color is white. But when you will see, because of there is low illumination, so it appears you gray. Okay. So just take the another example. So consider a black object under the bright sunlight. Okay. So there is low reflectance, like it observes the light, but even with the high illumination, it looks dark. I hope I am clear. So let's move further. The importance in the image processing. So what is its important in the image processing? So importance in the image processing. So it's separating the illumination and reflectance is useful for so separating illumination and reflectance is useful for For what? So image enhancement, image enhancement, like you're improving the contrast and normalizing image under the different lighting conditions. So normalizing image under different lighting coordination and the feature extraction, like you're ensuring light does not affect the recognition. Okay, so let's talk about the key takeaway from the today's video. So it is the first thing is your image. So illumination into reflectance. So image is your illumination into reflectance. So the illumination comes from the light source, reflectance come from the object surface. So this model helps to explain like why the same object look different under the different lighting. So that's about the simple image formation model, the basic equation that the concept of lighting and the surface properties to the image we captures. So in the next video, we shall explore the image sampling and quantization, the two key process that convert a continuous real-world image into a digital format that captures can actually understand. Okay. So see you in the next video. If you are enjoying this series, doesn't forget to like, share and subscribe. So तब तक के लिए keep learning and keep exploring. Thank you. Bye bye.